Bárðarbunga volcano, located in the center of Iceland, as shown in this map, had major activity in 2014 to 15. This map shows the shaded topography of Iceland, and on top of that, fissure swarms are shown with light shading, calderas in red, and outlines of central volcanoes in brown. Glaciers are shown in white. Bárðarbunga caldera lies beneath the northwestern part of the Vatnajökull ice cap. It's fully subglacial, as well as most of its central volcano, but fissure swarms they extend quite far towards the southwest and towards the northeast. This is a photo of this high-rising volcano. It shows a flat part on the ice cap. This is the ice-filled caldera. This second photo of the volcano was taken in September 2014, shortly after an eruption broke out some 40 kilometers northeast of the caldera. The red arrow shows the eruption plume. There was a link between activity under the caldera and the eruption. As the eruption progressed over a period of 6 months, gradual caldera collapse took place and the caldera subsided in total about 66 meters. The eruption turned out to be a major lava-forming eruption, as shown in this figure. The eruption site was located within the Holuhraun plain, north of the Vatnajökull ice cap. The eruption lasted for 6 months. It produced a lava field with a volume of 1.4 cubic kilometers, and tremendous amount of gas was released into the atmosphere. It was the largest effusive eruption in Iceland since the 1783-84 Laki eruption. Seismicity and ground deformation was well monitored during the eruption, partly thanks to the European Fieldwork project funded by the European Commission. The eruption occurred in the middle of this project. This map shows some of the monitoring data available. Seismometers are shown as inverted triangles and GPS geodetic stations as triangles. Filled triangles are continuously recording stations, and open are campaign GPS geodetic sites. The aerial coverage of SAR images from different satellites are indicated. Data from all these sensors proved to be very important to monitor the progress of activity. On 16 August 2014, intense seismicity started in the vicinity of the Bárðarbunga caldera. Here is a map of earthquakes as automatically located by the Icelandic Met Office over a period of half a year following 16th of August. There is a big cluster of earthquakes at the Bárðarbunga caldera itself, some earthquakes to the north and northwest, but then a very clear lineament extending from the caldera towards the northeast and outside the ice cap. During the first 24 hours, a cluster of earthquakes initially propagated to the southeast of the caldera, then took a sharp 90-degree turn and continued to migrate to the northeast for the next 2 weeks. Seismicity propagated about 40 kilometers in total beneath the ice cap, then continuing another 8 kilometers outside the glacier to the eruption site at Holuhraun. A minor effusive eruption started at midnight on 29 August at Holuhraun, lasting only a few hours. The main eruption began on 31st August 2014. The understanding of the activity became more clear when the earthquakes were relocated. The relocated earthquakes define clear dike segments shown in this map. The segments lie from the caldera and all the way to the Holuhraun eruption site. The recorded intense seismicity of over 22,000 earthquakes and associated deformation was representative of a segmented lateral dike injection. Here is a figure showing both the relocated earthquakes and horizontal ground displacements shown as arrows inferred from GPS. Earthquakes epicenter over the dike path and displacements are color-coded according to the time of occurrence, as indicated with the key at the top left. Other single earthquake locations are in gray. The arrows showing the displacements are of different type, depending on if there was continuous recording of displacements or not. The displacements show clearly how the land was split, with movement up to more than half a meter on each side. The red shading at the Bárðarbunga caldera shows subsidence up to 16 meters, inferred from radar profiling from airplane on 5th of September. This was just the beginning of the caldera collapse. The star marks the location of the magma source inferred from modeling. Circles along the dike path show ice cauldrons that formed, and the eruption site there is an outline of the new lava flow as it was on 6 September. Eruptive fissures are shown in white. These data signify a major rifting event at the plate boundary in Iceland.